session, we look at complex numbers, and the question says, given that z minus 1 equals z minus 2 all times e to the I alpha, where alpha is a real number, prove that z equals half into 3 minus I cot alpha over 2. This is also a GCE question. So the first thing is to copy the expression and we are simply required to make z the subject and then simplify. Z minus 1 equals, I open the bracket, I get it z e to the I alpha minus 2 e to the I alpha. The correct terms in z, I get 1 minus 2 e to the I alpha on the right hand side. Z is common on the left hand side, I factorize it, equals 1 minus 2 e to the I alpha. When I divide through by the bracket on the left, z should be 1 minus 2 e to the I alpha all over 1 minus e to the I alpha. The proof requires that z should be in this form. So we are obviously going to realize the denominator of this expression. And to do that, we need to take the conjugate of the denominator and multiply it up and down. The conjugate of a complex number in exponential form is not obtained by changing the sign in between like we do in the rectangular form. We instead change the sign of the power of e to have the conjugate. So the conjugate of this expression down should be 1 minus e to the negative I alpha, or change the sign of the power. So I should have 1 minus 2 e to the I alpha into the conjugate of down 1 minus e to the negative I alpha all over 1 minus e to the I alpha into 1 minus e to the negative I alpha. This would be equal to 1 times 1 is 1, 1 times that is negative e to the negative I alpha, negative 2 that times 1 is negative 2 e to the I alpha, and negative 2 e to the that times negative e to the negative that, all that should give positive 2, all over 1 times 1 is 1. We have negative e to the negative I alpha, negative this times 1, negative e to the I alpha, negative e to the that times negative e to the that, we get positive 1. So we have 1 plus 2, which is 3, minus e to the negative I alpha, minus 2e to the I alpha, all over 1 plus 1, we have 2 minus e to the negative I alpha, minus e to the I alpha. At this point now, to further simplify, you can see that the final expression does not have the exponential form again. So we start eliminating it after simplification. We have then that z should be 3 minus e to the negative I alpha is the same as cos alpha minus I sin alpha, and minus 2 e to the I alpha is simply cos alpha plus I sin alpha all over 2 minus e to the negative I alpha is cos alpha minus I sin alpha minus e to the I alpha cos alpha plus I sine alpha. And that gives 3 minus cos alpha plus I sine alpha minus 2 cos alpha minus I sine alpha. It should be 2I, sorry, all over 2 minus cos alpha plus I sine alpha minus cos alpha minus I sine alpha. This gives we have 3 minus cos alpha minus 2 cos alpha gives negative 3 cos alpha. I sine alpha minus 2 I sine alpha gives negative I sine alpha all over 2 negative cos alpha minus cos alpha will be negative 2 cos alpha, and then I sine alpha minus I sine alpha will be 0. So we're just left with this. At the numerator, the real part 3 factorizes to give 1 minus cos alpha minus I sine alpha all over 2 is common at the denominator, 1 minus cos alpha. Now the expression 1 minus cos alpha is actually 2 sine squared alpha on 2. Because if I write, this actually comes from cos 2 theta equals 1 minus 2 sine squared theta. So if I take half of half angle identities, I will get to this expression. So that's where this one is derived. And so I can make a replacement for it. 3 into 2 sine squared alpha and 2 minus I sine alpha all over 2 into 2 sine squared alpha and 2. And now I can distribute the denominator. To have this, the real part over the denominator just gives 3 over 2 minus I. Now sine alpha, since the other parts are in terms of half angle, sine alpha can also be expressed in terms of half angle as 2 sine alpha on 2 cos alpha on 2. I have to divide again by the denominator, which is 4 sine squared alpha on 2. Finally I get 3 over 2 minus half I into sine squared cancels the sine up, and I just have cos alpha on 2 all over sine alpha on 2. Therefore, z equals 3 all over 2 minus half I cot alpha on 2, because cot alpha on 2 over sine alpha on 2 is cot alpha on 2, which is the same as half, the factorizing half, 3 minus I cot alpha on 2 as required. We're asked to prove that z equals half into 3 minus I cot alpha on 2.